Now just go for the third part, the third component, which is the 18 picofarad capacitor. Again open the DC key over a new tab. Just search for the capacitors 0805, 18 picofarad, and enter. This is the ceramic capacitor also. Just select the ceramic capacitors first. Again I am going for the Vishay as a manufacturer. From here you can select the 18 picofarad. And apply the filters. Okay, so here I just forgot to paste the SMD there. Just again search for the capacitor 0805, enter. So now it will show the SMD also. Just click over the ceramic capacitors. Now select the manufacturers. (18 picofarad) and in stock. Okay, so with the EDA model it is not available there. Okay, so now the capacitors are apply filter. Okay, so here we go. As you can see, the 18 picofarad capacitor. So with the preference of minimum availability, I am just going for the first option. Just copy the part number, go to the Altium, go to the panel tab and part search, paste the part number there and search. So here you can see this component is okay with the minimum availability of 1. I am just imported that component, close the part search, select the name, the item ID and hide it. Now just place the pins there. Change the designator name to 1 and name to 1 also. Enter. For the second pin, change the designator to 2. Just name it 2 and designator is also 2. Enter. Fine. Now just select both the pins with the shift key and change the pin length to 100 mils. Enter. Now I'm just going to hide the designator and the names. Just go to the place line and just place the lines there as the capacitor symbol that we have created previously. Fine. Now select both the lines and change it color to blue. Okay. Just save the symbol. Again I am just going to add an extra parameter, which is category, and it is also capacitors in our case. So just copy the capacitors from the digi key menu and paste it here. Fine. Now we can go for the another component. Just go to the PDF. So it is a Schottky diode with a 0.5 ampere and 20 volt. So as you can see, there is manufacturer part number is also available there. So I'm just going to copy this manufacturer part number. Okay, so the vendor is Mauser, but I'm just going to use the digi key as a part provider. So here I'm just going to copy the Schottky diode. Just remove the extra symbols which comes there accidentally. Enter. So here paste the part number. In our case it is diode Schottky 0.5 ampere 20 volt. Enter. So there are 14 items available there. You can click over there. Just select a manufacturer. So I'm just going to select the micro semi there. Okay, so this is the component, the first one. Okay, so there the minimum quantity is 9,000, and yeah, the second one is fine because there is minimum quantity is 1. Okay, so just click the second option, copy the part number, go to the panel again, part search, paste the part number, enter. Now it is searching for the part. So as you can see there, so I'm just going to select the second last option. So there is the minimum quantity 1 available there. Just right click over there and go for the import this particular component. Okay, import into the first circuit SCHLib. Just hide this part number. Again, this is the diode, so we'll go for the pin placement first. So in this case the number of pins will be 2. Just press the space bar to rotate the pins. Okay, so for diode just I made a distance between the pin will be 4 block. Just select both the pins there. Sorry, firstly just change the name and the designator for each pin. Now just select both the pins. Just hide the name only and change the pin length to 100 mils. Now place the lines there. So I'm just going to make the first pin to the, and the second pin will be the P side of the diode. Just go to the place polygon. Yeah, fine. Right click. So we have placed a triangle there. Just press the shift key and change its color to blue. Yeah, fine. So we have created a symbol for diode also. Just save the symbol. Now go to the parameters, add another parameter. So there will minimum parameters are available there. It's okay. Add another parameter. Just name it category as we did for the previous ones. Go to the browser, copy the category. So it is a diode rectifier section. Okay, fine. Just copy the diodes. Okay, just copy the diode rectifiers, because this is the rectifier category of the diode. Just paste it here. Fine. Now we can go for the another component. So which is a 36 pin 1 row the connector J1 J2. Okay, so this is the connector that will going to create the symbol. So there are basically 36 pin connector, and we need to divide the each pin. So here I'm just going to create, the this not in whole, the 36 pin connector not in whole. I'm just going to create a 18 pin connector. Okay, because these are the J1 and J2 two components. So I'm just going to copy the manufacturer pin first. Let's see what happened. So here I'm just going to place the manufacturer part number from the mouser. Enter. Okay, so it is working for us. Okay, so now from the next time we'll go for just copy the manufacturer part number from the datasheet. Okay, so this is the 36 position and 1 row pin connector. So as I have planned, I am just going to create a 18 pin connector. So I'm just going to make the J1 and J2 differently. Okay, as you can see in the schematic sheet. Just go back to the DG key and search for the 18 position and 1 row header or connector. Enter. So here just I am going to selecting the 3M as a manufacturer. Okay, so these are all the connectors. Okay, so this is the 36 position. Okay, so here I am just going to apply the filter again. Just select the headers and apply filter, and the number of position 18 in our case. Now apply the filter. Select the number of rows to 1. Okay, so here it is, the first one, the 2mm 18 position connector with a 1 row. Just open this connector. So as you can see, just copy the part number, go to the panel, part search, just paste the part search, enter. Okay, so here you can see this is the connector, but its availability is not there. So just select the second option. Yeah, so its minimum quantity is 1 and it is also available. Okay, so I'm just going to import this connector there. Close, just hide this part number. Now we should create for this we should create a rectangular block first. Just place a rectangle. Just zoom out little bit using the wheel of your mouse. So it will be an 18 pin connector. So I placed a rectangle there. Now I can go for the pin placement. So before pin placement, I'm just going to change the pins designator and name to 1, enter. Okay, fine. Now we can go for the pin placement. So just pin up, before pin placement further, I'm just changing the grid to 50 mils by pressing the G. Just place the pins there. So if you are using different grid dimension, then it will be difficult for pin placement. So generally I'll use the 50 mils for the pin placement. Okay. Now place the 18 pins. (17, 18). Fine. Right click and just reduce the size of the rectangle, a single block. Yeah, now it's fine. It is perfect. So we have created the symbol for 18 pin connector. Just go for the parameter setting, add another parameter category as we did for the previous all the components, and just copy the category from the DZ key part number. So it is connectors, Control C and Control V. Fine. Now we can go for the another component. So it is a mini B USB connector. Okay. So it is a mini B USB connector which is placed right angle. Fine. So I'm just copying the manufacturer part number. Control C. Just go to the DZ key, open it to a new tab and paste. Just remove the other symbols. Enter. Okay, fine. So as you can see, the second option is perfect for us. Just open the second one, copy the DZ key part number. Yeah, so this is SMD USB mini B connector, as you can see. Just go to the panel, part search. Okay. Select the second option. Fine. Right click, import. Hide the part number. And before creating the symbols, I'm just go for the data sheet because I want to see the number of pins and number of pads for SMD placement. Okay, so as you can see there are 5 number of pins and 5 number of pins and 4 number of pins which are pads for the placement of the component. So there will be total 9 number of pins. Okay, fine. So again go back to the Altium designer. I just want to see the drawing also. Okay, so drawing is not available there. these are the, okay, so this is the manufacturer's website. Fine. So I'm just going for the pin configuration so that I can rename the symbol. Just search for the mini B connector pin out. Okay, fine. Mini B connector pin out. Just open the first image. Okay, so here you can see the first pin is the first pin is the VCC, second is data minus, third is data plus, fourth is ID, and fifth is ground. Okay, so this is the exact connector, as you can see. So now this will be very helpful. Just again go back to the Altium designer. Just place a rectangle first. One, two, three, 4, 5, 6. Fine. Just make it a little bit wider because we're going to place the pins at both sides of the component. So here, just before the pins placement, I'm just going to change the name and the designator to 1. Enter. Sorry, just name it 1. Okay. Just delete this pin. Okay, just make change here. Just change the name to 1. Okay, now it's fine. Just place this pin over the connector. Okay, fine. 2, 3, 4, 5, and we're going to place the other 4 pins at other side of the rectangle. Six, 7, 8, 9. Fine. Now we can go for the naming. So I'm just split the screen into 2 parts. Okay, just slide this menu a little bit. Okay, so now the symbol is visible. As you can see, the first pin is the VCC. Okay, so I think yeah, I made a mistake there. I need to just wide this particular menu and just slide the symbols a little bit to the left side. Okay, fine. Just change the name to the VCC for the first pin, enter. And the second pin, it is D minus, data minus. So just represent the data minus with the D minus, enter. And the third pin is the D plus, enter. The fourth pin is the ID, enter. And the fifth pin is ground. Fine. Okay, so like before naming the 6 to 9 pins, I'm just going to make it a little bit wider. So as you can see, the 6, 7, 8, 9, these are the ground pin. Okay. Just fit all the component. Just make this rectangle a little bit wider. That much is fine. Now adjust the pins. By pressing the shift and left click, just select all the pins and change the name to the ground, the G and D, enter. Fine. So we have created the symbol for the mini BUSB also. Now we can go for the parameter setting. So just select the item ID, go to the property, add another parameter, name it category, and just go back to the digi key part number, copy the category which is connectors, go back to Altium Designer and paste it here, enter. Now we can go for the another component. So it is a J5 connector. Just copy the manufacturing part number, paste it here, just open the new tab, paste, enter. So this is the J5 connector. I just want to see where is the J5. Okay, so as you can see, J5 is a ICSP 6-pin connector. It is a 3x2 6-pin male header. As you can see over the screen, it is a J5 header 3x2. Okay, fine. So they have made a mistake there. They have just provided the part number of a 72-pin connector. So it will not, definitely not work for us. This name, header 3x2, enter. Regular connector. Okay, so it will not work. It is a 3x23 pair. It is also different connector. It will also not work for us. So here just I am going to use the same manufacturer ID and just copy the name, because we're going to create the symbol and footprint from scratch. Okay, so I'm just going to create this, I'm just going to adding the property from this component, the 72-pin connector, but I'll create I'll create the symbol and footprint from scratch, so it will work for us. Just right click there, so again search for the part number. Here I am just going to search the 2-row 6-pin 6 position, enter. Okay, just select the first option, which is the headers or male pins. Just select the manufacturer. So I'm just going to select the 3M. Apply filter. Just select the number of positions to 6 and number of rows to 2. Apply filter. Okay, fine. Now you can see there. So I'm just going to open this option. So it is a 6 position 2.54 mm connector. Paste the part number here, enter. Yeah, so the second one is perfect for us. As you can see there, the number of rows is 2 and number pins is 6. Okay, fine. Just import this connector. Now hide the part number. So firstly I'm just going to place the rectangle first. So we're going to place a 6 numbers there, 6 pins there. So make the rectangle which is 4 pins, 4 blocks wider. Just change the designator and name to 1, enter. Place the pins there. By using the space key you can rotate the pins. Fine. So just remember the configuration. After the placement of third, we'll place the fourth as the bottom of the connector. Now we can go for the parameter addition. Just name the parameter to category. Just copy the category from the DGKey website, which is connectors. Copy, paste, enter, and save the symbols. Now we can go for the another component. So the another component is the LED, 0805 LED. So I'm just going to copy the manufacturing part number, Control C. Just paste it over a new tab of DGKey website. So I'm just going to use the new tab because we'll also, we needed a data sheet of each and every component when we'll go for the footprint creation. Okay. So the second component is okay. Open the second component, copy the part number. Go to the Altium panel, part search, paste it here, enter. Now select the second option, the minimum quantity is one available, import, close the part search there, hide the part number. So we're going to basically create a LED which is a diode. So there will be a 2 number of pins. So just change the designator and the name and place the first pin there. Just make the difference between the pins is 4 block and place the second pin also. Now I'm just going to reduce the length of the pin to the 100 mils. Enter. Just hide the name. Now I can go for the line placement. I'm just going to make the pin number 1 the N side and pin number 2 will be the P side of our component. Here I'm just going to place the polygon. Right click. Yeah, fine. Now just select the line option again. Then press the G on your number pad so we can move the cursor position accordingly. Here just I'm going to place a line there because it is a LED symbol, so we need to make it different from the diode symbol. So here again I'm going to select the polygon. Okay, fine. Now just change the color to the blue for each and every line. By shift, I am going to copy this particular glowing symbol for the LED, because for the LED case it minimum number of these symbols are 2. So this is basically common rule, either we can use it or not. So this we should at least make one for that, so that we can make it, symbol differently from the diode. Now just go for the category addition, sorry, parameter addition. Just name it category. Again go to the browser. So okay, so category LED, just paste it here. Fine. So our another component symbol is ready. Now we can go for the next component. So it is also an LED, which is a 0805, the same. Okay, fine. So now I am just not going to create these symbols differently. Okay, fine. Okay, the next component is the resistor. So this is the basically the resistor array, as you can see, where the 4 number of resistors are present there in a single component. So this is the 4 array register. Just open the digi key over a new tab, paste the manufacturer number there, enter. As you can see, this is the register array. Just select the second option, copy the digi key part number, open the panel, part search, paste it over the keyword section, enter. See there, the second is perfect for us. Import the second component. Just hide the digi key part number. Again, I just want to see the data sheet for this component, so that I can go for the exact pins placement. So I just want to see like what will be the pin placement there. Okay, fine. So as you can see there, for R1 there is a pin combination is 1 and 5. For R2 it is 2 and 6. Okay, fine. So I just want to see like where these register array are placed there. Okay, so they have just used the each and every registers differently in the schematic design. Okay, fine. So I just want to create the register array symbol as a whole. Okay, so I just don't want to create each and every register separately for a register array. So as you can see there, they have just used the each and every register differently in the register array in their schematic design. Okay, fine. So as you can see again, 2 is connected to 6, 3 is connected to 7, and 4 is connected to 8. Okay, fine. So when we will go for the symbol creation, we should place a pin 5 in front of 1, 6 in front of 2, 7 in front of 3, and 8 in front of 4. Okay, perfect. Okay, so the size of the register is 1206. So we should remember this while creating the footprint. Okay, so again I'm just going to place the rectangle first. So we need to create a 8 pin component. So for 8 pin component there will be a minimum blocks of 1, 2, 3, 4, 5, Okay, minimum blocks of 5. Place rectangle. Left click. Now we can go for the placement. Just change the designator and the name to 1. Rotate the pin by using a space bar. Again, I am just want to change the grid by pressing the G to the 50 mils. Just place the 4 pins at each side of the rectangle. Just remember that we should place the 1 in front of 5, 2 in front of 6. Okay. Now we can go for the parameter addition. Just name it category. So in our case it is resistors. Just paste it here. Okay, fine. So we have created another component. Just go for the next one. Okay, again the next component is the 4 resistor array, but it is a 680 ohm resistor. Open the DG key over a new tab. Just paste the manufacturer part number from the data sheet. Enter. Just select the second option. Copy the DG key part number. Go to the okay, so you can see here the data sheet is same as the previous one, but the resistance value is different. So here I am just going to use, just copy the DG key part number, go to the Altium designer. Again go to the panel, part search, paste the DG key part number, enter. Just import the second component, close, hide this DG key part number. Now I'm just going to copy this whole symbol because it is same for both the case. Control C, go back to the current one, Control V, and yeah, placed it like that. Fine. Enter. Again just add the category. Just change the parameter name to category. And it is same as the resistor as previous case. Control C. Fine. Save the component. Okay, so we have created the symbol for 680 ohm resistor array also. Now we can go for the next component. Just go back to the PDF. So here you can see the next component is a switch of 3 cross 2.5 mm square. Okay, fine. Just copy the manufacturing part number, go to the DG key, open it over a new tab. Paste it here. Just open the button, copy the DG key part number, go to the part search, paste it here, enter. So as you can see, second option is available with the unit price. Just hide this part number. Now we can go for the pin placement, because this push button is a 2 pin basically. there are 2 pin available, so I'm just going to change the designator and name to 1, enter. Just place the pin which is away from 4 block to each other. Fine. Just select both the pins. Just hide the name and the designator because there is no direction between the, and just change the pin length to 100 mils. Perfect. Now I'm just going to place the lines there. So place a 1 block length line first at a pin 1, right click, at a pin 2, just press a space bar. By that we can place a line there with a 45-degree angle. Left click, right click, fine. Just select both the lines and change the color to blue. Okay, so this is the symbol of the footprint, of the switch that we have created. Okay, so here just I need to place a curve also there. Just press a space bar. So I just want to make it a little bit fancy symbol that we have created. Now just go to the property section, add the category. So in this case the category is the switches. Just copy this particular category and paste it over Altium Designer. Fine. So we have created another component. Now we can go for the next component. So we have already created that Mega 168. Now we can go for the FTDI IC. So I just copied the DG key I just copied the manufacturer part number, which is the FT232RL. Enter. So as you can see, okay, this is not the connector. Okay, we have to select the IC. Okay, so there are 4 items available there. Yeah, this is the one. So these are the 28 pin ICs. So we can go for the minimum quantity of 1. Copy the DG key part number. So as you can see there. So I just want to see the data sheet before the symbol formation. Just search for the part over the Altium Designer. Okay, so this is the USB IC. As you can see, there are total number of pins is 28. Fine. Import this particular component, hide the part number. Now we can go for the rectangular placement first, because there are 28 pins there. So we can go for the placement of rectangle, which is 15 blocks wider, 15 blocks in length, and 10 blocks in wider. So these are the basically minimum scale that I can go for a clear symbol creation. Okay, fine. Now we can go for the pin placement. Just change the designator and name to 11. Enter. Just rotate the pin by pressing the space bar and place the 14 pin each side of the rectangle. Okay, fine. Just save this particular symbol. Now we can go for the naming. So just go to the data sheet. Okay, fine. So here you can see the each pins are available with its name. These the below are the description, so we don't want the description. So the first pin is the TXD. Okay, fine. So I am just going to split the screen again. So from here data sheet we will copy the name and paste it over the Altium designer. Okay. So I'm just shifting the panels a little bit and shifting the symbols to the left side. Just select the first pin. Okay, fine. So I'm just going to copy the first pin, which is the TXD in our case. Okay, now it's fine. Control C, select the first pin, Control V, enter. Similarly, copy the second pin, select the second pin over the Altium designer, Control V, enter. Just copy each and every pins there. Just copy the pin from the FTDI datasheet and paste it over the Altium designer symbols. So just change the name of the symbol and leave the designator as it is. Now copy the fifth one, paste it over here, enter. Select the sixth pin, copy the sixth one, paste it here, enter. Select the seventh one. Just be careful there. Just copy the copy the same pins from the data sheet and paste it very carefully over the Altium designer, because if you paste it wrong, then it will be difficult during the connection when we'll go for the schematic design. Okay. Now copy the last third pin, select the last third pin in the Altium designer, enter. So I will always recommend, like when you will complete this particular symbol, or which has multiple number of pins, so at least one time just tally the pins with the data sheet, because if there will be a issue, or if there will be a error, then it will be very difficult, because it can cause to uh, it can cause the errors in the schematic design also. If there is an error in the schematic design, then there will be an error in the footprint also, sorry, in the footprint also, right? And there will be an error in uh, the layout also, right? So it will ruin our whole project if we'll make a mistake there. Okay. So just place it very carefully and very slowly. You don't need to hurry up. So it is a task of patience. Now just copy the C bus 1, select the 22nd pin, paste it here, enter. Now we need to copy a couple of pins only. Fine. Now select the 25th pin, enter. Select the 26th, enter. 27th, enter. 28th, enter. Fine. So here we have completed the symbol of FTDI chip, which is a 28 pin IC. Now our next step is the parameter addition, and we should name this parameter. Okay, just don't forget to save each and every symbols, okay? Because if you will then run out of your battery of your laptop or system, or there will be a power cut, you will lost your you lost your all the libraries you have created, okay? So just make sure you save each and every symbols that you have created. Copy the category. Fine. Now we can go for the another component. Just go back to the PDF. Okay, here it is. The next component is a 5-volt regulator. So I'm just going to copy the manufacturer part number, open the DG key in a new tab, paste it here, enter. Okay, just select the option with the minimum quantity, copy the DG key part number, go back to Altium Designer, search for the part, enter. Just select with the minimum quantity, import to the Altium, just hide the DG key part number. So it is basically a 4-pin IC. I just want to see the data sheet. So here you can see, yeah, here you can see this is a 4-pin IC with the input. The first pin is the input, second pin is the common, and third pin is output, and the fourth pin is also common. Okay, fine. So common is basically ground in our case. So again, I'm just going to place a rectangle first. A rectangle with a length of 4 block. Fine. I just make it wider because we need to place the pins at both sides of the rectangle. Just change the designator and name to 1. Rotate the pins and place the 3 pins at one side of the rectangle and 4th pin at the other side. Now the next part is naming. So again, split the screen. So as you can see, just select the first pin. So in our case, the first pin is the input. First pin is input. So I'm just going to name the first pin. Enter. The second pin is the common. enter, select the third pin, which is the output, enter. Now the fourth pin is also common, so but before that I just want to make the rectangle little bit wider because there is an overlap between the second pin and the fourth pin. Okay, so just make it a little bit wider, that much is fine. Now slide the fourth pin and drag it here, change its name to common, enter. Okay, fine. So we have created the symbol for this regulator also. Now just add the parameter here, category, and change its category as it provided in the DZKey website. It is an integrated IC. Control V, enter. Okay, fine. Now we can go for the another component. Let's go back to PDF. So it is a 16 megahertz crystal oscillator. I just copied the manufacturer part number. Go back to the DZKey, open it over a new tab, paste it here, enter. So this is the component. This is a through hole oscillator, 16 megahertz. I just copied the DZKey part number. Go back to the Altium, search for the keyword, enter. Okay, so this is the component. I import the particular component over the SCH library. Close the part number, close the part search, select this DZKey part number, hide it. Now this is basically a 2-pin XT connector crystal oscillator. So just place a rectangle which is a 3-block wider and just change the designator name to 1, rotate by using spacebar, place 2 pins and just change its name to XT1, enter, and change the second pin name to XT2. So this is basically not polar or any directional, but I'm just going to place here the name differently. Save the component, go to the parameter, add another parameter, just name it category, and just change the category to copy, paste. So here we have finished with all the components which are necessary for the circuit designing of this particular microcontroller, as you can see. So in the next video we'll go for the footprint creation.